Good day. This work entitled Simulation of the Flow in a Fractured Rock, dealing with simulation the fluid flow in a porous media and simulation of the fracture in such media. The objectives: simulation of the transient flow in a porous rock block. Also, this work focuses on the modeling of the fluid flow in a porous material like rock. In such case study or media, the capability to simulate the fluid circulating is needed for heat extraction and for production. Therefore, we need to produce a crack or fracture. Why fracture? To enhance the flow into a porous media by increasing the cracking. As mentioned before, we need fracture for extracting the heat or for production. Also, to estimate the crack path based on the flow direction. Therefore, in this work, two softwares have been used. LISA software, this is this software for fluid simulation, and to estimate the fluid flow and velocity map in porous media using the transient porous analysis. And the second software is Frank 2D. This software will produce the crack and simulate the crack propagation in rock using the same fluid or the fluid pressure that was used in LISA software. LISA and Frank 2D capabilities. LISA is a free software simulation, can simulate or have different analysis such as thermal analysis, Darcy, and storativity can be investigated using LISA. Also, the velocity, permeability, and material parameter can be used as input parameters for the case study. The boundary conditions were investigated with respect to time because we need to simulate the transient porous media. As input parameter, we have to use the specific storage or to input specific storage, and Darcy constant have been used as input parameter. Unfortunately, LISA has no cracking simulation. Only LISA can do the fluid analysis and the transient analysis for porous media, in addition to thermal analysis and other parameters that were used for thermal and fluid analysis. Frank 2D software has been proposed as a finite element simulator for solid rock fracturing. This software, as compared with LISA, Frank has no fluid simulation, only the crack direction, crack propagation can be estimated and simulated within Frank 2D. The model that was used in this work, the first model on the left, the complete model with the central hole as shown in this figure on the left. Also the quarter model in case of one hole from the right, or in case of two holes in case of protection and in case of injection and production holes. This is the two-dimensional block model. As mentioned before, the central hole. Inside this block, we have simulated different cases, case of complete model and case of quarter model in case of one hole or two holes. The fluid loading is simulated directly by assuming a constant fluid velocity on the wall of the bore toward the continuum material. That means we have simulated the constant pressure inside the hole and toward the wall of the hole. Also in this model, the uniform initial ambient pressure would flow from the central hole have been used. The model assumes that the rock is porous and subjected to uniform pore pressure. Pore pressure is the pressure inside the cavity. As mentioned before, for the model within LISA, we need some input parameters such as Darcy constant is 1, was used equal to 1, and the transient porous analysis is used in LISA software. The velocity map or the fluid flow simulation velocity map as shown in these figures. For the porous media, the permeable flow and porosity of rock are interconnected by cracking. We have two cases, in case time 0 and in case time 1 day. Also, the pressure distribution for different time at 0 and at or after 1 hour. Actually, the pressure reaching to the steady state after 1 hour or 1 day. This is the graphical results for the pressure distribution as shown before. The pressure reached to steady state of a production after 1 hour. This is the pressure distribution in or at initial condition, and this is the pressure distribution after 1 hour and 1 day. For this time, the pressure reaching to the steady state of production. We mentioned before that we have simulated also the quarter models in case of two holes, one for injection and other holes for production. By using the same fluid loading or fluid pressure, we can simulate the fluid flow direction. Actually, the injection of a fluid will produce the fracture using the transient porous analysis from LISA software. As shown in this figure, the direction of a flow from right to left. Now we have to compare these results with the solid simulation from Frank 2D. If the same behavior or if the cracking direction has the same direction, if the crack propagation has the same direction from the injection toward the production. The simulation of a fracture using Frank 2D By using the same fluid pressure toward the wall of the hole, we can see the direction of a crack also has the same behavior or the same direction from right to left. Conclusions. The fracture can be estimated in porous media using LISA and Frank 2D. From LISA, we can estimate the fluid flow and velocity map, and from Frank, we can simulate the crack path. By using LISA, the fluid injection will produce a fracture. Hence, the crack propagation has been proposed, even from LISA software, as based on the direction of a fluid. LISA provides the user with new software for fluid simulation in rock using transient porous analysis. Finally, by considering the fluid direction from LISA and fracturing from Frank 2D, the location of a crack and their dimensions can be estimated according to the velocity map. Thank you for your attention and for your invitation.